IoT Cloud Technologies Incorporated designs, develops and secures IoT cloud technologies to empower the 21st century. Weather Anticipating Package Terminal Air Conditioner, PTAC Controller. Our patent-pending weather anticipating PTAC controllers connect to the internet through wireless networks and obtain weather forecast data to reduce energy consumption and maximize comfort levels in hotels, motels, senior housing facilities, hospitals, condominiums and apartment buildings. Typically the PTAC is connected to a wall thermostat with switches. The switches control the heating or cooling mode of operation and the fan settings. During warm weather, someone in the room must switch the thermostat to cooling mode for the cooling to work. Once the cooling mode is selected, the cooling will be automatically controlled by the thermostat. When the outside temperature gets cold, someone in the room must switch the thermostat to heating mode and the heating will be automatically controlled by the thermostat. If the days are hot and the nights are cool, then someone will need to switch the thermostat to heating at night and back to cooling as the room gets hot during the day, resulting in wasted energy and damage to the thermostat by constant manually switching between cooling and heating. This example is from Figure 5 of our patent filing, and overlays the weather forecasted temperature data 501 with the room zone temperature data 502 over 24 hours. Note: night or unoccupied setback is not included in this example. At 0000, the system is in heating mode as the outside temperature is below the room zone temperature set point of 69 F20.5 C and the room zone temperature is maintained around this temperature. At around 0600, the weather anticipating programmable thermostat goes into heating energy conservation mode and lowers the set point 503 because the weather forecast indicates that the outside temperature will be above the set point 504. The room zone temperature drops to the lower set point 505 and then the heating is activated to maintain the room zone temperature. Once the actual outside temperature rises above the room zone temperature set point, the system is automatically switched to cooling mode. The room zone temperature rises to the cooling set point of just below 25 C, 77 F, and the cooling is activated 506. At around 1500, the weather anticipating programmable thermostat goes into cooling energy conservation mode and raises the set point 507 because the weather forecast indicates that the outside temperature will be below the set point 506. The room zone temperature rises to the higher set point 508 and then the cooling is activated to maintain the room zone temperature. Once the actual outside temperature drops below the room zone temperature set point, the system is automatically switched to heating mode and the room zone temperature is maintained at the heating set point 509. The weather anticipating programmable thermostat calculates the amount of time for heating and cooling energy conservation modes by recording the temperatures during previous energy conservation modes. In this example, the heating energy conservation mode was activated at 503 about 4.5 hours before the anticipated rise in outdoor temperature from the weather forecast data 504. In order to minimize discomfort caused by the heating being lowered 505 below the set point, the next heating energy conservation mode cycle would be shortened so that lower room zone temperature 505 occurs around 0900. Likewise, to minimize discomfort caused by the room temperature rising above cooling set point 506, the next cooling energy conservation mode cycle would be shortened so that higher room zone temperature 508 occurs around 1700. Should the room zone temperature drop below the minimum cooling heating changeover setting 511, the system is switched to heating mode. Likewise, should the room zone temperature go above the maximum changeover set point 513, the system is switched to cooling mode. Should the room zone temperature exceed 515 or drop below 517, an alarm signal is generated and transmitted by text message and or email to appropriate personnel. Room occupancy status is sent wirelessly to the weather anticipating PTAC controllers from front desk registration systems, alarm systems, key card access systems, etc. For added security, all data is encrypted using transport layer security (TLS) cryptographic protocols, the same protocols used in online banking systems. For additional energy savings, the weather anticipating PTAC controllers communicate wirelessly with each other and other systems to automatically reduce peak electrical demand. In most cases, it is easy to upgrade existing installations with the weather anticipating PTAC controllers. The PTAC controllers can be installed within the PTAC with an external or internal temperature sensor, or the PTAC controllers can be wall-mounted like a thermostat. This concludes the short YouTube presentation on our weather anticipating PTAC controller. If you are a building owner or manager with over 100 PTACs and would like to reduce operating costs and improve comfort, please contact us at 100PTACs@iotcloudtechnologies.com. If you are HVAC controls or PTAC manufacturer and would like to inquire regarding OEM licensing of our technologies, please contact us at OEMlicensing@iotcloudtechnologies.com. Investor inquiries, please contact us at invest@iotcloudtechnologies.com. Thank you for your time.